In this chapter, we are going to study the electricity, how the electricity flows, and we'll also study about the electric circuits and its its uses. Uh, Electricity is an important place, has an important place in a modern society. It is controllable and convenient form of energy for variety of uses at homes, schools, hospital, industry, and so on. So, what constitute electricity? How does it flow in an electric circuit? And what are the factors that controls or regulate the current through the electric circuit? And in this chapter, we shall attempt to answer such questions, and we shall also discuss the heating effect of the electric current and its applications. So first topic is the electric current and circuit. What is the electric current? Electric current is expressed by the amount of charge flowing through a particular area in unit time. This is a wire, and the amount of charge flowing through it per unit time is expressed as electric current, and it is a rate of flow of electric charge. So electric current is a rate of flow of charge. Flow of charge is electric current. If there is no flow of charge, there will be no current. We have seen, electric current. We can imagine this way. In near sea, we see the water currents, water waves. These are the water waves, and we have the water currents. Like in beaches, we see, like, uh, you know these water levels, like, become more and larger. This happens at the water level. So it water goes there and comes up, goes there, comes up. These are the water currents. So similarly, uh, we have also electric currents. When the electricity will flow, when the charge will be flow, when the charge will flow in a particular conductor, then there will be the electric current. uh, Flow of charge forms electric current. If there is no flow, there will not be current. Conventionally, in an electric circuit, the direction of the electric current is taken as opposite to the direction of the flow of the electron, and which is negative charge. So in an electric current, the direction of the electric current is opposite to the direction of the flow of the electrons. So if the electric current is this way, the flow of electron will be this way. Current, current. How we can, like, mathematically describe this? If a net charge q flow across the cross section of a conductor in time t, then the current I through the cross section will be, then electric current will be, uh, the net charge flow, the amount of charge flow per unit time. We will measure time in seconds. So this formula is equal to electric current I equal to q upon it, q upon t, and q will become it, where the charge we express in the coulomb, and current will be expressed in ampere, and potential difference that we will discuss later is in volt. An electron has this much charge. One electron has it has a negative charge. This is minus, and minus 1.6 into 10 to the power minus 19 coulomb. So coulomb is a unit of charge. A SI unit of electric charge is the coulomb, which is equal to the charge contained by nearly these electrons. So if each electron has this much charge, so how much electron will form a 1 coulomb charge? So that much electron, 10 into 6 into 10 to the power 18 electrons will form 1 coulomb of charge combinedly. An electron possesses a negative charge of this, and electric current is expressed by a unit called ampere. So this charge will be in ampere, this time will be in second, and this current will be in ampere. So our charge in coulomb, and this was there is a anti-Mary ampere, and 1 ampere constitute the flow of 1 coulomb charge per second. So this is a electric 1 ampere will be here, current will be q upon it. So it is expressed in the ampere. So 1 ampere will be 1 coulomb upon 1 seconds. The flow of 1 coulomb charge per second will equal to the 1 ampere of current. Okay, and small quantities of current is expressed in the milliamperes, and in microamperes. Milliamperes in 10 to the minus 3 ampere, and microampere, milli means 3 and micro means minus 7. And the instrument that measures the electric current is called ammeter, and it is always connected in a series. So this is ammeter, it is connected in a series. It will measures the electric current in ampere, always connected in series in a circuit through which the current is measured. Electric current flows in a circuit from the positive terminal of the cell to the negative terminal of the cell through the bulb and ammeter. So this electric current will flow from positive terminal of the cell this way to the negative terminal. What is the electric potential and potential difference? We know the potential difference, like there are two buckets of water here. It is almost filled, it is half filled. So if you connect these by conducting a rod, what will happen? Here the water potential is a more, due to gravity, and here is the come. So water will flow from this direction here, and the potential, the flow depends, the rate of flow, whether it will be slow or it will be fast, depends upon the pressure here. More will be the pressure, more will be the potential difference between them. Less will be the potential difference, less will be the flow of water here. So here the potential, potential is deciding, potential difference is deciding the rate of flow of water here. Similar things happens in case of current. Similar thing. To flow the charge in a conducting metal wire, the gravity of course has no role. In this case, in case of electricity, gravity has no role. Like we have in case of water, but electrons move only. The electrons move only whether there is a difference in the electrical pressure. So if there is a electrical pressure, so this electrical pressure is called potential difference. So electricity, electron only move when there is a electric pressure, difference of the electric pressure, and this electric pressure difference is called potential difference. Suppose this is a wire, and here is a current. Suppose here are like 100 billion electrons, and here are only 10 billion electrons. So there is a potential between, charge potential difference is there. So potential difference will be there. So what will happen? Electron will move from the 100 billion electron towards the 10 billion electrons. This will happen, and this difference of the potential may be produced by the battery consisting of the more and more electrical cells. Chemical action within the cell generates the potential difference across the terminals of the cell. So cell generates potential difference. Suppose we have here the cell, and I generated a potential difference of this much 90 billion electrons. So the electricity flow this way. The potential difference between the 2 points in an electric circuit carrying some current is a work done to move a unit charge from one point to another point. What is the potential difference then? potential difference will be measured at the work done to move a unit charge from one point to another point. You might have remembered that when we were discussing about like potential kinetic energy and potential energy of an object in our motion classes. And in that case, kinetic energy comes from the motion of any body. And how the potential energy comes from? Potential energy because of its position, position and its shape. So we also studied there that key potential in this case, potential energy in this case will be the work done, will be equal to the work done in lifting the body, in that position. Suppose I have stressed a rubber, and rubber stretches this way, and the work done while work done on stretching the rubber wire will be this, is equal to the potential energy. So similar thing is happening in the uh, electric potential difference. It is like work done to move a unit charge from one point to another point. The work done that will we do is a potential electric potential difference. So potential difference between 2 point will be the work done upon the charge. Its SI unit is a volt. Volt is the SI unit, and 1 volt is 1 volt potential difference between the 2 point of the current carrying conductor when the 1 joule of the work is done to move the a charge of the 1 coulomb from one point to another point. 1 volt upon it is joule upon coulomb, and joule coulomb minus this is how we explain the volt potential difference. Potential difference is measured by means of the instrument called voltmeter, and is always used in a parallel way. And this is a wire. We have to measure its potential difference at this point to this point. So we cannot put it in series because we need two things na. That is why we can calculate difference. It is talking about difference. For difference of what? Two things. So it will be connected in the parallel this way. So this is a voltmeter here. So here in this y there will be same there is no potential difference. Why? Because same the current here is suppose 10 ampere, here will be the 10 ampere. So there is no potential difference. So how the potential difference create? By by using something here which consumes some electricity. Suppose we have some device here like light bulb here, a resistor here, a TV here, which consumes some amount of energy, and then the potential difference which it will create. And suppose it is consuming 5 ampere, and only the 5 ampere will reach here. So this will create a potential difference here between a 10 to 5. Let's talk about the circuit diagrams. So in circuit diagrams we have a symbols, components. We use electric cell is symbolized by this way, and combination of cells battery we symbolize in electric signal this way. For switch we have this, and open switch is this is a closed switch where there is a button, this means close. This is a joint wire, and this shows the wire is crossing, not joining, they are crossing. And this shows the electric bulb, this shows the resistor means which resist the flow of electron, the flow of current. It resists the flow of current. This is a variable resistance, and this is ammeter which measures the electric current in ampere, and this voltmeter measures potential difference. And we study Ohm's law. Ohm was the guy who just gave this theory. He was a German physicist. What he says, the potential difference across the end of a given metallic wire in an electric circuit is directly proportional to the current flowing through it. It is provided its temperature remains the same. So it is saying more will be the potential difference, more will be the flow of current, more will the current. So this I have already explained in a water tank, water tank. More will the potential difference, more will be the, so level of water is this way, and in this water level is here. Here the potential difference is, suppose this is the potential difference, this much is height is a potential difference. If I increase this water level here, its potential difference increases by this. And if the potential difference, it is due to the gravity in case of water, so the flow of the electricity will be higher rate in a water in this case will flow at a higher rate. As it slows down, it comes here, the potential difference become less, the water flow will be less. Similar thing happen in electricity. More will the potential difference, more will do the current flowing current, and less will the potential difference, less will the current flowing. So the potential difference is directly proportional to I, and when the directly proportional signs removes, there appears a constant, and this constant is resistance. R is a constant, and that gives the metallic, for a given metallic wire at a given temperature. So this R is a resistance for the metallic wire, suppose iron, copper, silver. So these restrict flow of the electrons, flow of a charge, and and because of this they heat up, because energy can neither be created nor be destroyed. So the extra energy goes in heating up this. Ohm is a SI unit of resistor, and 1 ohm equal to 1 volt upon 1 ampere. Current through a resistor is inversely proportional to the time. Current through a resistor is inversely proportional to its resistance. So more will the resistance, less will be the current flow, and less will be the resistance, more will the current flow. The component used to regulate the current without changing a voltage source is called variable resistance. This is a component which regulates the current without changing the voltage. This is called variable resistance. A device, rheostat, is often used to change the resistance in a circuit. Motion of the electron through the conductor is retarded by the resistance. The motion is retarded by the resistance. We know that like non-conductors are those who do not conduct electricity. Why? Because they resist the flow of the electrons, they resist the flow of the current through it. Like rubber resist, glass has a highly resistive properties. So resistance of the conductor depends upon, first its length, area of the cross section, and nature of this material. Like I just discussed rubber and glass, it depends on the nature of the material. Along with that, it also depends on the length and the area. So they are directly proportional. The resistance, more will the length, more will the resistance, and area of the cross section is inversely proportional. Like more will the area of the inverse cross section, its thickness. This is about the length, and this is about the cross section. This small correction. More is the area of the cross section. Here resistance will be the low, and here the area of cross section is a very low. Cross section is high, so resistance will be low. Cross section area is here is comparatively low, less, so resistance will be the high. And nature of materials depends upon this rho. It is called electrical resistivity of a material of a conductor. It is different from the other material. It will be different for the aluminum, it will be different from the different conducting elements like copper, silver, gold, aluminum, silver, you know, even the glass, rubber, and all that. And its SI unit is resistivity. Uh, me- Metals and alloy have a very low resistivity at a range of this, and so they are good conductors. And insulator like a rubber, glass have a high resistivity, so they are a bad conductors. Resistivity of a alloy is generally higher than the constituent metals, and alloy do not oxidize readily in high temperature. For this reason, they are commonly used in the electrical heating devices. Alloy are used because they do not get oxidized quickly, and like in iron, electric iron or toaster, tungsten is a most exclusively for the filament of the electric bulb, used exclusively for the filament of electric bulb, whereas the copper and the aluminum is generally used for the electrical transmission lines. So conductor has a low resistivity, so they are good conductor. Alloys a medium resistivity. They conduct they conduct electricity, but not as good as and fast as these. An insulator has a very high resistivity, so they do not allow current to pass through them. Resistance of a system by a resistor. Current through a conductor depends upon the resistance and potential difference across it, and we have already know this. And methods of joining the resistor. There are two methods. One is series, joining a resistor in series, and here the total resistance. And another way is through parallel. What happens in case of series? When we you know when we put resistance in a series, this way in an electrical board, so the equivalent of the all resistance from this one, this V will equal to the sum of the V1, V2 and V3. in series, arithmetical this arithmetical sum of these. And in case of parallel, resistance will be this, and when the several resistors are joined in the series, the resistance of the combination are equal to the sum of their individual resistance. So total resistance will equal to the sum of the individual resistance, thus greater than any individual resistor. So what happens in case of parallel? In case of parallel, when the resistance are in parallel this way, so the resistance, total resistance can be calculated by this formula: 1 upon R equal to 1 upon resistance of 1, 1 upon resistance of 2 plus 1 upon resistance of 3. So thus the resistance become, this is more efficient, parallel combination of resistors is more efficient. Thus it is obviously and impracticable to connect the electric bulb and electric heater in a series, because they need a current of widely different values to operate properly. And another major disadvantage of the series circuit is that when the one component fails in the series is broken, one component fails in the series, none of the components works. Have you used the fairy lights, over festival lights, Diwali lights? When bulb fuses, all the series bulb fuses, because these bulbs which are acting as a resistor, uh, you know are placed in a series way. On the other hand, parallel circuits divides the current through the electric gadgets. In parallel, they divides the electric current, and the total resistance in the parallel circuit decreases per as per this equation. So total resistance will decrease. This is helpful particularly when the each gadgets has a different resistance and requires a different current to operate properly. So in our homes, wherever where we need heavy lightings, we connect resistance in parallel. This is the last topic, which heating effect. Let's quickly revise it. The chemical reaction within the cell generates a potential difference between the two terminals that sets electrons in a motion and to flow the current through a resistor or a system of the resistor connected in a battery. To maintain the current, the source has to kept expanding its energy. Where does the energy goes? A part of the source energy in maintaining the current may be consumed into the useful work like rotating the blades of the electric fans, and rest of the source energy may be expended in a heat to raise the temperature of the gadgets. If the electric circuit is purely resistive, uh, that is the configuration of the resistor or only connected to a battery, the source energy continuously gets dissipated entirely in the form of heat. This is known as the heating effect of the electric current, and this effect is utilized in a device such as the electric heater and electric iron. Suppose this is a wire, and uh, it flows the electricity, and more will the resistance, less will be the flow of the current. So where this current is going, if we are passing like uh, is passing some current. So if it is restricting the current, so where is this current going? This current is going in the form of dissipating in the form of heat, and this dissipating current in the form of heat is known as heating effect. And more it will restrict, more it will heat up. So in electric heaters we use highly resistive material so that it will hardly allow flow of current, and most of the other energy, electrical energy will be used for heating this wire. It will give a heat and it will produce a light and all that. It will glow up light, it will glow, so it will produce light. So what happens when the energy expended by the source, this gets dissipated in the resistor as a heat. So this is a formula. This is known as a Joule law of heating. Law implies that the heat produced in a resistor is directly proportional to the square of the current for a given resistor. This is square of the current. So heat is dependent upon the square of the current. It's also directly proportional to the resistor of the current. More will the current, more will the heat, and also the more will the resistance, more will the heat, and also the directly proportional to the time by which the current flows, and more will the time, more will the heat. It is this T I square RT. Let's talk about the application, practical application of the heating effect of electric current. The electric So these are practical applications. The electric laundry iron, electric coaster, electric oven, electric toaster, oven, electric kettle, heater are the devices which we are familiar with, and they depends on the Joule's heating. Based on this formula, heat will equal to the I square RT. Electric heating is also used to produce light as electric bulb. So we have this old homes light na, this way, where here the wire, when it has a high resistivity, so it heat up and produces light, this wire. Now we have a LED which don't work like this. In earlier days we have a bulb like this. So that it gets very hot to emit light. this wire. And tungsten is a material which is used for making the bulb filament. This is the bulb filament. It is a high resistivity, and the bulb is usually filled with a chemically inactive nitrogen and argons, so it has a prolonged life. It do not get oxidized. Most of the power consumed by the filament appears as a heat, but a small part of it forms it in the form of the light radiated. So most of the energy goes, electrical energy goes in the in heating, and some goes in the light, in some goes in a radiated light. So even it also warms up the room, also produces the electricity, sorry, a light. What is a fuse? A fuse is a place in a series with a device. It consists of a The fuse is placed in a series with a device. It consists of a piece of wire made of a metal or alloy of an appropriate melting point. And if the current larger than the specific value flows through electric circuit through the circuit, the temperature of the fuse wire increases. This melts the fuse wire and break the circuit. This fuse wire for a domestic purpose is rated as 1 ampere, 2 ampere, 3 ampere. So for our safety purpose we have a fuse. What it does was, more electricity is more high voltage, electricity is coming, it quickly heated up and it breaks the wire will break because it heats, it melt down, so electricity will not flow. So it saves our households, electric devices from the from damage, high voltage electric damage. Electrical power. So electric power is a uh, v P equal to V, and SI unit of electric power is a watt, and 1 watt equal to 1 volt into 1 ampere, and watt is a small unit. Therefore in actual practice we use much larger unit, which is a kilowatt. Kilowatt is a which contains 1000 watts. Since the electrical energy is a product of power and time, and the unit of the electrical energy therefore is a watt hour. So in our homes we use a kilowatt hour unit, and this kilowatt hour has 6 into 10 to the power 6.3.6 10 to the power 6 joules. And let's quickly revise this chapter. SI unit of the electric current is ampere. To set the electron in the motion of the electric current, we use a battery that creates a potential difference across the terminals, and this potential difference is measured in the volt. Ohm's law says the potential difference across the end is directly proportional to the flow of current. V equal to V directly proportional, B is directly proportional to I, and resistance of a conductor depends directly on its length and inversely in the area of cross section, and also on the material of the conductor. What material is used? Iron, silver, copper. And when resistance are resistors are lined up in series, the equivalent resistor will be sum of the individual resistors, and we found the resistance in case of parallel. Electrical energy dissipates in resistor with this formula, and power unit of watt is a 1 watt is a power consumed with 1 ampere current flows at a potential difference of 1. 1 watt of power is consumed when the 1 ampere of a current flows at a potential difference of 1 volt. And in commercial units we use kilowatt hour unit, and 1 kilowatt hour has a 6 into 10 to the power 6 3.6 into 10 to the power 6 joule of energy. Here ends this chapter.